I will be putting this up into my courses under content, under dossier. So you will be able to access this. Okay? Just didn't get the audio started right away. Right, let's take solve by square root. Not every quadratic equation works well solving by square root. So I wouldn't use this method all the time or go to it all the time. I'm going to do two problems solving by square root. So I want to isolate x squared. Notice I do not have a linear term here. And that's an advantage because what I can do is I can either subtract 5 from both sides and factor the difference of two squares, or I could subtract 1 and take the square root of each side. Either method. But remember that there are two solutions, positive and negative 4. Now let me show the other method just so that you can see this as well, what I was just talking about. And that is to subtract 5 from each side. And now you could factor this as the difference of two squares. This is really not by the square root method, but we're factoring this into positive and negative 2 because we need the product to be negative, but we do not want a middle term. And then by the time you set each of these factors equal to 0, you get the two solutions that we just got by square root. So on the left is by square root. On the right would be how you would solve this by factoring. Okay, let me take one other problem by square root. I don't want to go quite that far. All right, so let's take this one. I don't want to multiply this out, x minus 1 times x minus 1 by FOIL. I now say I could take, it looks as if this would work very well by square root. So I'm going to take the square root of each side. Square root on the left-hand side just gives me x minus 1. However, on the right-hand side, I get positive and negative 16. And then I take care of the two possibilities. X minus 1 equals positive 4. X minus 1 equals negative 4. And then if I add 1 to each, I'm getting two solutions, 5 and negative 3. And of course I check those in the original. 5 minus 1 squared is 16, and negative 1 minus 3 squared is also 16. So this problem worked well by square root, but not by expanding the left-hand side. It was already in a form that lent itself very well to square root. Let's solve by completing the square. And by the way, this doesn't eliminate your going to the notes that I have on each one of these sections. I have those 1.1, 1.2, 1.4, 1.5 that walks you through all of these aspects from My Math Lab, from the textbook. I'm eliminating that and doing problems, which I feel are better than my just reading those notes to you and going over that. You can do that on your own. Okay, so let's take a problem like this one. Not every problem works well by completing the square, and it's a little bit more involved. Here is the process that you use. First, you want to move the constant to the other side of the equation. So we just have x squared plus 2x is equal to 5. Now, you have to take 1/2 the coefficient of the linear term. 1/2 the coefficient of the linear term. So 1/2 of 2 is 1. Square it and add it to both sides of the equation. Let me repeat that. Take 1/2 the coefficient of the linear term, square it, and add it to both sides of the equation. So I'm going to add 1 to each side of the equation. Now, what that does on the left-hand side is it creates a trinomial that can be factored, and it can be factored into x plus 1 times x plus 1. Both of them are the same, equals 6. So now what I have is x plus 1 quantity squared equals 6. And we just talked about how to deal with a problem like this, because we could solve this